In this video, I'm going to take the ESP8266 and connect it to the WS2812 LED Strip. All these fancy numbers, but it means I've figured out how to get it to do magic like this. So I've bought myself some other ESP8266 related goodness. Now this is known as the NodeMCU dev board. You can find these on eBay for about £5 or £6, so they're about £2 dearer than the bare board. And it's broken out all of the I/O pins, so including the one analog pin, all of the data pins, and the data D0, D1 here. They match the numbering used in the NodeMCU map. So they're not the numbers of the GPIO pins on the ESP, they are the NodeMCU map numbers. You get this strip of LEDs, so this is an RGB LED strip with addressable LEDs. So I'm going to try and get that hooked up to one of these. It's got a plug here with power, ground and signal, and an extra power and ground here. So I suppose if you wanted beefier power for a longer strip, you'd put it through these with the high current thick cables. So my theory is that the 5 volts from the USB cable will be coming in on V-in, being regulated to 3.3 volts for the ESP, and the ground will just be common. 20 volts range, 4.56 volts, that'll do nicely for now. Green, brown and red. Red into the 5 volts, brown into ground, and we'll put green to pin D1. On the LED strip, red, 5 volts. Now I'm slightly forcing these connectors on. Brown to ground and green to the data in. Into continuity mode, ground. Okay, we have voltage in. I'm kind of not expecting data to come all the way to the end here. And we can try it, but I think it's got to actually do data through for that to work, so I'm not expecting continuity there, and plug that in. Now let me go to the NodeMCU API, and I'll put links down below. WS2812 write RGB, and then I put in a pin. We've got to do string.char because we've got to convert numbers to a set of characters. 500. Did anything happen? We don't have a light. So either one of two things is happening. Either my signal, well, three. My signal's going to the wrong pin, my signal's not getting through, or there just isn't actually enough juice to light that light. And when I'm trying to light that light, the voltage is dropping. The last one I can probably measure on that V in, V out with a quick measurement on my multimeter. So let's just see what I've got. If I take got a ground pin, reference ground pin next to my analog pin. Oh, hello. Right, I'm on the 20 volt range, and I'm putting my probe, so one is across V in and one is across ground, and I'm getting 0. Well, I didn't expect that. Okay, we'll disconnect those. Okay, we've got 4.5 volts. That's entirely reasonable. Let's put in a power and a ground, and I've got 0 volts there. Okay, at this point I'm wondering if I need to try and separately power the LED strip, which I suppose in an eventual target I would have to. And just share a common ground here. Take a DC input voltage, I've got my DC supply, apparently 1.2 milliamps. So this is already set up on 6 volts. Okay, after a bit of a good rummage in the robot cupboard, I've got a pair of croc clips which I can connect over here. I saw that light up as I did that. So it's shared ground, separate voltage, share, obviously shared data. Let's try going and writing a red to port 1. Ha! What if I then did green and blue? Hey! Okay, so the key for this working is that it's got to be externally powered. I wonder if, given 5 minutes, I can get it to do something fancy. Can I get a purple colour? That's purple. So now I'm going to see if I can get it to maybe do a 29-way flicker. Okay, so first thing is I've got the right RGB, and I presume if I also write RGB 000, then the first LED will go off. Okay, let me work out a little light following demo, and if I run it, first it shows multicolours and then that. Unfortunately at that point it reboots because I suspect I've run out of memory. Do file and WS LED Strip.Lua. I could probably even get it to do that in multiple colours. Go for there. Okay, let's see if I can get that to roll colours. Sweet. Let's get a closer look at what I've been doing with this. So this is my ESP8266 module, and this is apparently the Lolin development board. It's got nice breakouts here. It's very simple to work with. A USB connector here, USB to serial, regulator here. There's your actual ESP module, and with all those pins broken out, you've got plenty of I/O. So connecting it to the LED strip, which is the WS2812 B, which apparently operates from about 3.5 volts to 5 volts, although it still works with 6 without any damage. I've connected first here this ground pin, so G for ground, to the ground pin here on this plug. So if you look, there's ground, well, that brown pin going to this ground here, which goes into the LED strip, and this green cable here is going to data pin 1 here, which is actually the index pin 1. So it's GPIO 5, I believe. It's index pin 1 in the NodeMCU IO map. So that's getting connected to a similar green cable there, which is the data in on our device. But I'm not getting power from this because I've not found that to work. So since the voltage always reduces to 0, I'm always using external power. Now if you look closely here, you'll notice there are 5 cables coming out of it. These 2 here are for a higher current supply. I've been using this, which is a universal power supply. Initially I had it set to 6 volts, but now it works quite happily off of 4.5. I've got an adapter there, and that actually terminates in a pair of croc clips. So the croc clips attach nice and easily to those, and this data line is going to get through. I have to make sure the 2 grounds are connected. And bear in mind that voltages are always relative to something else, so they've got to be relative to a ground, so that's why I've got to have those connected. Right, let's get a close-up of the thing running. Now, one thing I should be able to do is drive this just from this supply here. So I'm now connecting that red cable there. Let's connect that red cable here. Let's see if the whole lot will work off of that. Awesome. I was finding that it kept stopping after going so long, and it didn't seem to matter how many LEDs, it seemed to be a matter of time. So what I was missing there is that the 8266 has got a watchdog timer, and you have to reset it or in some way tell it you still want to carry on. I was in a while loop. The while loop was never going to reset that counter because I hadn't told it to. So if you're in a while loop on this, you either need to reset the counter, or because this is NodeMCU, it's expecting you to think like Node, in which case use an alarm. So an alarm is like a function that will get called back on an interval. So instead what I've done is I've kind of set it up so in the interval it will increment a couple of different counters. In fact, it's incrementing one because the yellow LED is going the inverse of the other multicolour LEDs. I think as it goes, I think that demo looks pretty neat. I'll tell you what I'll do. Just for full effect, I'm going to turn off the lights. It's also doing some quite eerie things to the room doing this. Stop the timer, you do tmr.stop and give it the timer number, and that'll stop it moving. Just how much illumination do you get from this 29 LED strip? So what I'm going to do is I'm going to do it all in white. Now the other thing that's worth knowing here is Lua has got a string rep function which repeats strings. So when working with this strip, use the rep function, use string rep to repeat strings. It's one of the simplest ways to say I want 29 white LEDs. If I do a write RGB and it's on pin 1 and I say white rep 29, we've got full illumination from white LEDs, and that is, it's not as bright as say one of my studio lights or just the standard ambient lights, but it's probably bright enough to illuminate a small space. It's got a certain intensity. I wouldn't want to look at this. There's obviously no diffusion or not a lot of diffusion going on compared with say a standard lamp. But I mean, you can reduce that intensity, I'm sure. So if I was to say string.char 60, 60, 60, okay, for something a bit less bright than white. There we go. So there's a dimmer light with a hint of green. Oh, that's quite an eerie colour. Well, okay, I hope you've enjoyed this. And yes, WS2812 LED strips, which have got a data in and a data out, and you might even be able to get it to be sneaky and use this I/O pin for more than one thing, because any extra bits sent past the last data out just get outputs through here. Oh, look at that. Light beam pointing straight out of that. Isn't that awesome? That's probably just a bit of lens flare, but that looks pretty cool.